Let's look at 7.2. 7.2, we're verifying trigonometric identities. For example, something like this, verifying that secant squared of x minus tangent of x times cotangent of x is equal to tangent squared. Here's the deal with verifying trig identities. When you verify a trig identity, you are trying to transform one side of the equation into the same form of the other by using only trig identities and algebraic properties like distributive property, factoring, canceling, or common denominators of fractions. You can transform either side, or both can be transformed until you get them both to match. But here's the catch. What you are not allowed to do is you are not allowed to add or subtract quantities from one side to the other of an unverified identity. For example, if I was trying to prove this is true and say, hey, it might be a little bit easier if I subtracted secant squared of x and put that on this side right here. No! You don't want to do that. Can't do it. So, here's a couple of tips. First thing that we want to look at here is, usually you want to transform the more complicated side into the simpler side. Looking closely at this one, we can see that the left side is definitely more complicated. So we're going to turn that into tangent squared. What we're going to be doing here is, if we look at the next move here, let's do some reciprocals here. Now notice what they chose to do here. Cotangent is equal to 1 over tangent. What they saw right here is that they had tangent of x times cotangent here, and realize if you take tangent times cotangent, those will cancel out and you'll get 1. This might not have been the way that we would have done it before. A tip that I kind of shared with you guys when it came to simplifying back on 7.1 is that you want to change everything in terms of sines and cosines. So one might think that this would be the move to go here. 1 over cosine squared of x minus sine of x over cosine of x times cosine of x over sine of x. Notice what happens here is that the sines will divide out and the cosines will divide out to be 1. So notice it doesn't really matter whether you change it to sines and cosines, or if you see this right away and you switch it out to say 1 over tangent. Either way, this stuff right here is going to turn out to give us 1. And now we have secant squared minus 1. One thing that we notice now is that if we look closely at secant squared minus 1, secant squared minus 1 equals tangent squared minus 1. That's actually this identity right down here. So what we could do is maybe take this secant squared that's right here, this secant squared that's right there, and let's write tangent squared plus 1 in its place. And now notice what happens here with these ones. See it? And so now we've proved the identity. A couple things that make identities look really good looking is when you have all the equal signs lined up. Okay? When you're all over the place, that makes it really tough for me to follow your work. For example, take a look at this student's work. As you can see here, what I like about it is the equal signs are all lined up. They didn't change that side. And notice they did all of their trig work here until eventually they got them worked out right here. If I wanted to do one thing here, maybe we would have moved this little final statement here, maybe just a little bit over there to line up with the equal signs. But other than that, it's fine. Let's take a look at a not so great looking one. If you notice here, they're all over the place. I don't know what's going where, and you can see right there, I just kind of wrote, I'm lost. I have no idea what's going on there. So you got to make sure that when you have those equal signs lined up, it logically follows with each one of the steps too. Let's look at another one where the steps don't logically follow. Alright, so look at this student's work. This makes sense, going from this step to here. Nothing wrong here. They use trig identities. Tangent squared is sine squared over cosine squared. Cotangent squared, cosine squared over sine squared. Here's where they got into trouble. There is no trig identity here that states that cosine squared over sine squared is 1. Nor is there one that says sine squared over cosine squared is 1. There's nothing that states that. So since there's no trigonometric basis for what they said there, that makes this statement invalid, it makes this invalid, and it makes this not true. So let's try this out on a problem here. Let's look at this one here. Let's show that the cosine of x is equal to cotangent of x divided by cosecant of x. When I do my work, I like to draw a line there just to remind myself that we aren't going to be crossing over that line. Okay, now the more complicated side looks like it's the right side. So here we go. One move we can make here pretty easily is let's change everything to sines and cosines. So now I have cosine of x over the sine of x, and then cosecant there is 1 over the sine of x. Understand here that now I have this fraction divided by that fraction, so it makes sense to me that my next logical move would be multiplying by the reciprocal. So let's take cosine of x divided by the sine of x. Let's multiply by the reciprocal, which would be sine of x over 1. What's going to happen here? See a sine, and now our result here is the cosine of x, and we have successfully proved this identity. How about this one? Let's put our line in here, keeping in mind not to cross over it. Now the more complicated side here, I don't know. I'd probably say that this side's a little bit more complicated just because I can think of a move I could make here, which is changing the tangent and secant here. Now, since that 1 is not affected by changing it to sines and cosines here, keep that 1 on top. And now underneath, let's write it as sine of x over the cosine of x plus 1 over the cosine of x. One thing to notice down here, both of these two down here have a common denominator. So we can write that as 1 fraction. That 1 up on top is unaffected still. So we have 1 over sine of x plus 1 all over cosine of x. That's our next move here. I think what we can do now is, since we have 1 divided by this fraction here, let's multiply by the reciprocal. When I multiply by the reciprocal, multiply by 1 doesn't change it, so all I'm left with is a reciprocal here. So logically it makes sense that we have cosine of x over the sine of x plus 1. Now do we need to do any more work? We have cosine of x over sine of x plus 1, and look, it's a match up there. Excellent. Alright, so those are pretty easy. Let's kick it up a notch. Let's take it up to 11. Let's look at some trickier problems, like these ones here. Notice that it's not very obvious which one is the more complicated side. So what we're going to do is we are going to transform both sides until they match. So first move here on both sides is let's just look at the left side. Looking at the left side, I see cosecant and secant. So how about we switch that up and use our quotient identities and write that as 1 over sine and 1 over cosine. A natural fit for our next move here, just on that side, would be multiplying by the reciprocal. So now if I multiply by the reciprocal here and the reciprocal here, flip it over, I'm really actually taking this sine of a and multiplying by a sine of a, taking this cosine of a up there and multiplying by a cosine of a. So what we get here is sine squared plus cosine squared. Now wait a minute, sine squared plus cosine squared, that's one of our Pythagorean identities. Take a look at your blue sheet. Blue sheet has that on there in the Pythagorean identities section. So we can transfer that and make it a 1. Now what about the right side? Now with the right side, I see cosecant squared minus cotangent squared. We could rewrite that into sines and cosines, but I see something else here. What about that Pythagorean identity here of 1 plus cotangent squared equals cosecant squared? I think I could rewrite cosecant squared as 1 plus cotangent squared. And notice if we do that, now I have 1 plus cotangent squared minus cotangent squared. Hey, those cotangent squares can take a hike. And now I'm left with 1, which matches that one. It's a match. Let's take a look at this one. Sine times tangent. Well, I guess I could write that as sine of theta times sine of theta over cosine theta. which would give me sine squared theta over cosine theta. Now what about this side? I have 1 over cosine theta minus cosine theta. I'm going to put that cosine theta up there just a little bit, keeping in mind that's really cosine theta over 1. So now I'm stumped here. I'm not sure where to go. When you're stumped, maybe you might want to look at those denominators and see if we can write one fraction out of it. Hey, this is an easy one to manufacture a common denominator. If we got a 1 down there, all we really have to do here is multiply this one by cosine of theta over cosine theta. So if we multiply just that fraction, now I have 1 over cosine of theta minus cosine squared of theta over cosine. I can write that as one fraction. 1 minus cosine squared of theta over cosine theta. Now that 1 minus cosine squared theta is kind of got my interest. Why? Well, I'm thinking of the Pythagorean identity of sine squared plus cosine squared equals 1. Can I create a 1 minus cosine squared here situation? I sure can. Or could I replace just this 1 right here with sine squared plus cosine squared? I could do it that way too. I'm going to manipulate this known identity here, and I'm going to write it as 1 minus cosine squared. So notice with this gone, now it's sine squared. So what I'm going to do is replace that cosine squared here. 1 minus cosine squared, let's replace it with sine squared of theta over cosine squared. Hey, look at that. It's a match. So there we go. There is proving trig identities. There's going to be quite a few gnarly ones there. On your assignment, I definitely recommend taking a look at your proto page, check the solutions that are there, and ask me if you're stumped on any of their moves that they made there.